In the realm of intellectual exploration, two enigmatic concepts take center stage: perplexity and burstiness. Perplexity gauges the intricate nature of textual content, while burstiness evaluates the diversity in sentence lengths. Contrary to the uniformity often observed in AI-generated sentences, human authors infuse their creations with a dynamic blend of concise and extensive sentences, enhancing burstiness. As we delve into this thought-provoking topic, we also aim to enrich our discourse with rare and distinctive terminology, elevating the depth and uniqueness of our narrative. The fundamental inquiry into the workings of our world and the existence of reality itself has captivated human minds since time immemorial. Does an objective, tangible reality exist independently of our perceptions, or is it a construct shaped by the minds that observe it? We routinely accept our sensory experiences as an accurate representation of the world around us. However, two distinct fields of study, neuroscience and philosophy, offer divergent viewpoints on the very essence of reality and our perception thereof. Neuroscience asserts that our brains, the architects of our reality, fashion our experiences by processing sensory input into a cohesive model of the world. This model, our reality, guides us in making predictions based on past encounters and sensory input. Yet we must pause to question the accuracy of this mental construct. Could our brains, prone to deception and susceptible to optical illusions, inadvertently distort the world's true form? Conversely, philosophy contends that reality exists independently of our mental constructs, insisting that it stands as an objective entity accessible through reason and observation. Here lies the conundrum. If our senses are the conduits to understanding reality, how can we place unwavering faith in their veracity given their susceptibility to fallibility? This philosophical quandary, known as the problem of knowledge, persists, leaving us to grapple with the tension between subjective perception and objective reality. The quantum paradox, modern physics, particularly the enigmatic realm of quantum theory, intertwines itself with the age-old debates surrounding the nature of reality. Quantum theory, which surfaced in the 1920s, unraveled the perplexing behavior of atomic and subatomic particles. These entities exhibited both localized, particle-like attributes and non-localized, wave-like properties, confounding physicists and philosophers alike. Parmenides, a pre-Socratic thinker, once argued that the world perceived by our senses is illusory. He contended that true reality, immutable, unified, and timeless, lay beyond the grasp of our sensory faculties. The philosopher posited that our senses, unreliable in the quest for truth, only unveiled appearances. This notion endures, suggesting that physical reality may not be as concrete as it appears. Quantum mechanics, born out of the pursuit of the infinitesimal, transformed our understanding of reality. Niels Bohr's description of the atom introduced particles behaving both like electrons orbiting in a miniaturized solar system and like elusive, probabilistic entities. This discovery underscored the bewildering distinction between the microscopic world and the macroscopic reality governed by classical physics. The quest for fundamental building blocks. In the quest to fathom the essence of our cosmos, physicists embarked on a journey to identify its most elementary constituents. The journey led them to subatomic particles such as quarks, electrons, and neutrinos presumed to underpin all matter. Yet, the narrative transcends particles. It extends to the very fabric of space-time. Albert Einstein's theory of general relativity merged space and time into a singular, four-dimensional entity known as space-time. Within this framework, gravity materializes as the consequence of massive objects distorting the curvature of space-time. But the quest for fundamental building blocks persists, with information emerging as a compelling contender. Information as the cosmic blueprint. Recent advances in information theory have thrust the concept of information into the spotlight. Information is defined as a measure of uncertainty within a system, encapsulating our ignorance about its intricacies. In the realm of quantum mechanics, information assumes a central role, exemplified by the observer effect, where measurement fundamentally alters a quantum system state. The holographic principle proposes a breathtaking notion. Information may constitute the very fabric of space-time itself. It posits that three-dimensional information can be encoded, onto a two-dimensional surface, akin to a hologram. In this paradigm, the universe unfolds as a holographic masterpiece, with information serving as its foundational building blocks. The quantum universe as a cosmic computer. Recent breakthroughs in quantum computing have underscored the significance of information in the universe. Individual particles, acting as carriers of information, can be manipulated to perform intricate computations. This revelation hints at the universe as a colossal quantum computer, where each particle functions as a unit of information, perpetually generating and processing data. Perceptions and deceptions. Our perception of reality, as the philosopher Carl Sagan astutely noted, is a story crafted for us by our brains. While this narrative often aligns with the physical world, it is not infallible. Our brains, in an effort to comprehend the world, occasionally skew our perceptions, bending them to conform to our desires, expectations, and past experiences. The intriguing conundrum of consciousness, the elusive nature of consciousness, perpetually baffles us. Is it an internal observer, as John Locke suggested, enabling us to reflect upon our thoughts and experiences, or does it arise from the integrated information processing of our brains? As contemporary theories posit, the origin of consciousness remains shrouded in mystery, with an ongoing debate over its presence in various organisms, including humans, animals, and even microscopic life forms. Existence as a simulation. The tantalizing idea that our reality might be a hyper-realistic simulation has gained traction in recent years. Visionaries like Nick Bostrom suggest that future civilizations could create such simulations, wherein the vast majority of sentient beings exist within these artificial constructs. This intriguing proposition raises profound questions about the nature of our existence and the identity of the original programmers, a concept reminiscent of science fiction tales like The Matrix. Conclusion: as we navigate the labyrinthine corridors of perception and existence, the question of reality's nature lingers. Whether we exist within a cosmic simulation or amidst a universe governed by enigmatic laws, the pursuit of knowledge remains our guiding star. We must persist in our quest to uncover the truth, for it is through inquiry, exploration, and open-mindedness that we inch closer to unraveling the mysteries of our existence. The enigma persists, and our journey continues.